So welcome to the exercise 5. This is going to be the last exercise of our video series. So in exercise 4 we achieved movement of the Pac-Man character in one direction. In exercise 5 what we are going to achieve is we are going to change motion direction with keyboard interaction. So based on the 4 keys on the keyboard, which are arrow keys, left arrow, up arrow, down arrow and right arrow. If user presses the left arrow, we want to show the left character, which is this one, the first one. So we want to show it moving in the left direction. Then if user presses the right arrow key, we want it to move into the right direction. Up arrow, this is the character to be picked, and down arrow, this is the character to be picked. Now let's take a look at the code and the changes that are required. For now, let's run the code that we had written in the previous exercise, and that's working, and it's moving the character in one particular direction. So since we want keyboard interaction now, we want our Pac-Man panel to listen to the keyboard events. So we want some part of event handling in our code. So the way to listen to keyboard events is to implement a key listener interface, which is defined in java.awt.event package. So let's go ahead and add a line, implements key listener. So that is the interface to implement, and let's import proper package for key listener. So this is the package. Now since this is an interface, this interface provides 3 methods which are abstract, and since we are implementing the interface, we need to provide the implementation of all 3 methods inside our class. So key listener, let's go to the end of jpanel class and add those 3 methods. So it's public void key pressed, and it takes a parameter key event, which is passed to us automatically. The second one is key released, that also gets key event, and third one is public void, it is key typed, which is mixture of pressing the key and releasing the key. So these are the 3 methods that we will have to override and provide implementation to. So this is the method we are interested in to implement to know which key user has pressed. So before making some choice, making some decision, we want to check which key user has pressed, because our actions depend on the key pressed by the user. So we will be using switch case to take action based on the key user has pressed. So the way to know which key user has pressed is e.get key code. So that is the function we are going to use from key event class. So if I were to take you to the documentation of key event, then this is the key event class, and it provides us a method get key code, and get key code returns us an integer whose values we can verify using some constants that are defined in the key event class. So vk underscore down is the static final constant defined in this class, which will tell us there is a key, down key has been pressed by the user. So let's add these cases to our switch. So in case user has pressed this key, we want to take some action. We'll update this in a short while, but before, since we are using the key event class, we need to add an import statement here. So we can say import java.awt.event. All the listeners and events, they are part of the AWT event package. So after adding this line, we can get back to the code, and based on the down arrow key, we need to add some code here. Now we can notice once user presses the down arrow, that is the bottommost, then what are the parameters we require to draw these images? So image selection out of sub images, it will happen based on the index, based on the row count that we are picking. So let's make this change from 2 to x, and x will be updated based on what key user has pressed. So now we can see if user has pressed the key down arrow, then 0, 1, 2, 3. The x should be pointing to this fourth row and it will be index 3. So let's make this change as x equals 3. Now we also need to update xp accordingly. So xp will be updated if we are moving down, then actually character moves from top to down. So essentially, if we pay attention, xp does not change at all. What is changing is y, and y is changing in a positive direction, because when we go down we are increasing the y axis. So we should be changing yp so here we should be saying yp equals yp plus d. So this is the displacement that we added in previous exercise. Now what will happen if the Pac-Man character goes out of the screen? It goes to the height of the panel and it will go down and it will keep on moving in the downward direction. So we want to reset yp to 0. Once the character moves out from the height, we want to reset it to come from the top. So the check we will put is if yp is greater than equal to this dot height, it should be this dot get height, then what we want to do is yp is 0. So that's the change we'll make. So with that code, our down arrow key should become operational. Now same way we will add code for up arrow, left arrow. Okay, just a moment. Yeah, copy paste this code here and we make the necessary changes. So let's paste it here. Now if the case is up arrow, let's see what are the changes we want to make. For up arrow, the image to be picked is the second row and index for that would be 1. And now rather than changing y in the positive direction, we have to change y in the negative direction. So yp will become, sorry, this is unnecessary d. Yeah, so yp will become yp is equal to yp minus d. Now since yp is changing in a negative direction, we have chances that the character will cross the top corner of the screen, the top edge of the screen. So we'll make it, if yp is less than 0, that means if character moves in negative direction, then we will reset yp to this dot get height. So that's the change we'll make to yp. So that implements the second case. Let's implement two more cases, which is left key. Now if we go to the left side, that means this is the image we want to pick. So our x is going to be 0. Now rather than changing the yp, we need to change the xp, because direction of x is changing, and that too in negative direction. And same way, if xp is less than 0, we want to set it to get width, because once character moves out from the left side, we want it to come from the right side. So that's the change will be required here. And same way, let's put the change for right arrow key. So let's paste the code. Now if it is right, the image to pick would be 0, 1, 2, second row, third row, which is index second. So we make x2, yp here, xp will change in a positive direction, and if xp is greater than equal to the get width, so in case character moves out from the right side, we want it to come from the left side. So we will make xp equals 0. So these are the necessary changes that were required. Now in animate function, we don't need to change xp, because xp change has been brought as part of the key pressed event. We just need to ensure the default value of xp is in the right direction. So let's select the second index. So we are going to show 2, so that character will be facing right. And for now, when the game starts, character won't be moving because we are not changing XP here. So whenever we press the first key, that's when the changes start happening. So now this is the code we have added on key pressed event, but what essentially we wanted our character to move based on the call to animate function. So what we will do, based on the key pressed, we are going to add one more variable which will tell us the direction of move. So we will call it int direction, and initial value of direction, let's set it to key event dot vk underscore right. So that's the direction we are going to set, and once the key is pressed, now this code we want it to be executed as part of our animate method. So in animate, let's move this code and let's run this code based on the value of direction variable. Now direction variable will be updated based on what is the key user presses. So if user presses any key, direction will change, and this is the code that will take action based on the direction. Now after adding this code, one last thing that we have to ensure. So right now this class is implementing the key listener interface, but still we have to attach a key listener to this JPanel, so that whenever a key is pressed, the appropriate method can be called. So in the constructor of this class, we'll say this dot add key listener, and we provide current object as the listener object. And one more change we need to do. In order to listen events in a panel, we need to set its focusable property. So set focusable should be set to true, otherwise we will not be able to receive the key events in the panel. So now this is set to true. We have added this based on direction, which value is changing, we have added that logic here. Now we are drawing the image based on the value of x, y, xp and yp, and that's going to be the code. So let's try to give it a run. Now we see character is moving towards right. If I press the down arrow, it starts moving in the down direction. If I press the left arrow, it starts moving in the left direction. And now I am going to hit the up arrow key, it goes in the up direction. And once it goes in the up direction, if I don't press any key, it comes out from the down. If I press the left arrow, it comes out from the right side. If I press down arrow, it comes again out from the top. So that way we have brought in the keyboard interaction for this character, and that will be the end of this series.